Hello. So this semester project was done by Adrian Avendano, Daniel Solorzano, Camarenas, and Sofia Gutierrez. A project overview would be us creating a calculator, and both written in Python and Java. This calculator would just have basic functions such as adding, subtracting, multiplying, dividing. It will take a user input for the values, and for another part, we do use the UTEP login page, which will be shown in the following slides. The testing tools and techniques that were used in this were the unit testing and coverage and IntelliJ IDA, and also PY unit, which is for Python. Any other relevant tools not covered in the course that we did demonstrate were coverage.py and testng framework.
Okay, so I'm going to talk about unit testing using IntelliJ IDE. Pretty much what we did here is just created a calculator system, and it just has basic functions of a calculator, so we can add and subtract and um, divide and multiply. Uh, so this is just the main, we're running it. Um, and then we created this calculator test. So what I'm doing with this calculator test is simply testing to see if our different functions of the calculator work correctly. So this first one would be our test addition. So we're just testing if the addition works correctly. And I only did one test for this one just because it is a simple testing. Um, but yeah, this is a test one and I can run it right here. And we notice that our test has passed our testing addition. They test division, subtraction, and test division and test addition are pretty similar. The one that I would like to highlight is the test division. So what I did in test division is that we cannot uh, divide by zero. So I threw an exception here. So if the second value of the value we're dividing by is zero, then our test here will throw an illegal argument exception. So when we run this, I entered it with a zero on the second value alongside with a positive integer, and it throws that exception. So that test is passed. All of them are pretty simple tests as well. We can also run all these tests at once just by running it here on the class. And that's what I did. So all these processes are starting, each one of them, and then we can see that the tests have all passed once we run all of them. And that is it for JUnit testing with IntelliJ.
Testing and coverage.py. So first I'll be talking about unit testing in Python. It was inspired by a unit and it has a similar flavor to every other unit testing framework in other language. It basically supports test automation, aggregation of tests into collections, and independence of the test from the testing framework. Um, so it has really the same concepts that we see in other unit testing frameworks. Then I'll be talking about coverage.py. Coverage.py is a tool for measuring code coverage in Python. Specifically, it basically monitors the program and it notes you which parts of the code have been executed and which ones have not been executed. So It basically tests the effectiveness of the tests in this case. And then finally, the critical assessment of these two tools is that it's mostly a pretty straightforward process. You add the test and see if the coverage improves. It is relatively easy to set up for small projects and to measure coverage. Some of the cons for this tool is that most of the tasks in here, as you can see in the image, this was done by ourselves, which is very manual. So when you have really large code bases, it is really difficult to be implementing test cases for each single module or class that you have. So now I'll be talking about the project itself that we tested. So we have the calculator code base, and on the left we have the class definition in Python. So we have all the methods, and then the getters and the setters finally. And then on the right, we have the test cases. So here are the test cases that I did. I did one for each method, and those are going to be explained by.
Alright, so for the PyUnit coverage report on our calculator, shows what conditions were met and which were not. So on the left side, you can see what was covered, the percentage, and what was missed. More specifically, you can always produce reports in a number of formats, including text, HTML, XML, LCOV, and JSON. For us, we did demonstrate the HTML, which is shown on the right side. Here you could see a more user-friendly report, and it even shows the specific line on where the coverage wasn't shown. So for sure on our get value, we need to tweak it a little more just to show 100% coverage. Again, like Adrian was talking about, the pros and the cons of this, or critical assessment. The higher the code coverage, the lower the chance of having undetected bugs, of course. The only thing is that, of course, even if it does show 100% coverage, it won't show complete accuracy. Other than that, I mean, it is pretty straightforward, and I mean, you just have to add tests to see how coverage improves, which again means it still won't be 100% like accurate, but I mean, at least it'll demonstrate coverage. And other than that, I believe it's good because it also will test if all the branches in the codes, for example, if else conditions. We didn't have any of these, but I mean, if it did, then it still show that in the report.
Okay, so I'll be talking about TestNG framework. TestNG is a powerful Java-based testing framework for unit, integration, and functional testing. It is based on JUnit, and it is considered to be a strong tool and a strong competitor for JUnit. And the reason I chose TestNG is because it makes it easy to use multiple annotations. In this project, the following four major annotations were used. So I have before method and after method, which are just self-explanatory. These annotations run before and after each test method, and then before class and after class, and they run once before and after the first test method in a class, and then they execute in the following order. So to get started in writing the first test, I had to create a testing class with the annotations I had previously mentioned. And then once I clicked finish, it generated the following class with the defined methods, which is the image that you see on the right. So in this code, I automated the sign-up flow using these annotations, and again, the code that I was using, or the project that I was using, was the UTEP sign-in page for Blackboard. So this is automating the sign-up flow for the Blackboard sign-in. And then again, I use these annotations. So before class sets up the browser, before method opens the UTEP homepage, test performs the sign-in functionality, after method prints the current URL, and then after class closes the browser. So next it was time to execute the report, which will show the methods that passed and failed the test. As you can see, our test passed. And then typically after this is done, the user does want to validate the test methods. So in order to validate test methods with testng, it provides assertions for it. So similar to JUnit, we have assert true, assert false, assert equals, and assert not equals. However, I am not showing this step since it is identical to the process we showed earlier in our presentation with JUnit.